You think you understand how disease works? Germs make you sick, wash your hands, cook your food. Basic, right? But in 1857, none of this was obvious. People believed wine turned sour because bad air infected it. They thought maggots appeared in meat from nothing. They trusted that life itself could spring from dust and rot. And then a 45-year-old French chemist named Louis Pasteur walked into a beetroot factory in Lille and saw something nobody else could see. Not with his eyes, with his method, the way he thought. The mental process that would crack open reality itself. Because Pasteur didn't just prove germ theory, he proved that you could force the world to reveal its secrets if you asked the right questions in the right order. That's what changed everything. Not the microscope, the method, the way he thought his way from confusion to certainty while everyone around him screamed he was wrong. Also, this script is researched and factual, using sources from Gerald Geisson's The Private Science of Louis Pasteur, published by Princeton University Press in 1995, the only comprehensive work examining Pasteur's actual laboratory notebooks held at the Bibliothèque Nationale in Paris, restricted until 1971, and not catalogued until 1985, and from original Comptes rendus de l'Académie des Sciences. Publications from 1857 through 1885, the primary documents recording Pasteur's announcements in his own words. Now back to the information. Something that tastes like spoiled milk. His vats are turning into acid instead of spirits. He needs help. His son studies under Louis Pasteur at the Faculty of Sciences. Bigot asks Pasteur to investigate. Pasteur agrees. This moment matters because of what Pasteur does next. He doesn't theorize, he doesn't guess. He goes to the factory floor and looks. Not standard equipment for solving industrial problems in 1856. Most chemists would analyze the chemical composition, suggest temperature changes, blame impure ingredients. Pasteur goes smaller. He samples the successful batches and the failed ones, takes them back to his laboratory, puts droplets under his microscope lenses, and he sees something nobody expected. The successful batches contain spherical cells, yeast globules, round, uniform, multiplying in the sugar solution. The failed batches contain these same yeast cells, but also rod-shaped organisms he's never seen in alcohol fermentation. Long, thin bacteria. He watches them move, counts them, measures their proportions. In failed batches, the rod-shaped bacteria outnumber the yeast. And when he tastes the failed product, sour, acidic, nothing like alcohol, he makes the connection. Under his microscope, Pasteur sees two different shapes in the failed batches. Round yeast cells. Rod-shaped bacteria. The successful batches, only yeast. The failed ones, bacteria multiplying, producing lactic acid instead of alcohol. Same sugar, different organisms, different products. He documents this, counts the organisms, measures the acid, then he takes it further. He isolates the lactic bacteria, grows them in a controlled medium, adds them to fresh milk. The milk sours. He removes the bacteria. No souring. He publishes this in August 1857 in Comptes rendus hebdomadaires des séances de l'Académie des Sciences, volume 45, page 1032 through 1036. The paper states, fermentation is not a chemical breakdown. It's a vital process caused by living microorganisms. Each organism produces a specific product. Yeast makes alcohol. Bacteria make acid. Specificity, that's the key insight. One organism, one outcome. Or do they come from other microorganisms? This is 1857. The dominant theory, believed for 2,000 years since Aristotle, is spontaneous generation. Life springs from non-life. Maggots from meat, mice from grain, microbes from broth. It's not superstition. It's mainstream science defended by respected researchers. Francesco Redi in 1668 showed that maggots don't spontaneously appear on meat if you keep flies away. But that only pushed the question smaller. What about microorganisms? Antony van Leeuwenhoek discovered them in 1677 using early microscopes. Ever since, scientists argued whether these animalculas generated spontaneously or reproduced like larger organisms. Lazzaro Spallanzani in 1768 boiled broth in sealed containers and showed nothing grew. Critics argued he destroyed the vital force needed for generation by removing air. John Needham argued the opposite, showing that broth in sealed containers still developed microorganisms. The methodological trap was clear. Seal the container, critics say you blocked vital air. Leave it open, contamination from the environment makes the test useless. Félix Pouchet, director of the Rouen Museum of Natural History, has just published experiments in 1859 showing microbes arising in sealed flasks. The French Academy of Sciences is so divided they offer a prize, the Al-Humbert Prize, worth 2,500 francs, to whoever can settle the question. Pasteur reads Pouchet's work, studies it, writes him a letter in April 1861 asking for details. The letter is respectful. He calls Pouchet a colleague. says he's editing observations that will criticize Pouchet's conclusions. Pasteur is preparing to destroy the man's theory, but he needs to understand it first. That's the process. Know your opponent's argument better than they do. Air can still enter through the open neck. That's critical. Pouchet and others argued sealed containers blocked some vital force and air needed for spontaneous generation. Pasteur's design lets air in, but traps dust particles and microbes in the curves of the neck. Gravity works against them. They settle in the bend. They can't reach the broth. Some of these original flasks, sealed in 1861, are still sterile today at the Pasteur Institute Museum in Paris. But here's the control that makes it devastating. Pasteur takes identical flasks, boils the broth the same way, then breaks the swan-neck, straight shot for dust. Within days, the broth clouds with microbial growth. Same broth, same air. The only difference? The physical barrier. No spontaneous generation. Microbes come from microbes already in the environment. The experiment is presented to the Academy in 1861, published in full in 1862 in Mémoires sur les corpuscules, organisés qui existent dans l'atmosphère. The Academy awards him the Al Humbert Prize, February 1862, 2,500 francs. But more important, credibility. The ammunition to fight every doctor, scientist, and philosopher who believes disease springs from bad air and imbalanced humors. Swan neck versus straight neck, everything else identical. When the results differ, you know which variable caused it. Sounds obvious now. In 1861, this level of experimental control is revolutionary. Scientists are still mixing observations with assumptions, correlation with causation. Pasteur strips it down to, if I change this one thing, what happens? Then he documents it with obsessive detail. His laboratory notebooks, held secret by his family until 1971, examined by historian Gerald Geisson in the 1990s, show daily entries, temperatures, times, measurements, drawings of what he sees under the microscope. He's not guessing, he's recording reality. Because if spontaneous generation is false, if life only comes from life, that has implications. Religious implications, political implications. Materialists like Pouchet believe spontaneous generation supports naturalism, the idea that nature alone creates complexity without divine intervention. Pasteur, raised Catholic in Eastern France, sees it differently. To him, proving life comes only from life suggests a creator was needed for the first life. The debate becomes radioactive. Pouchet performs his own experiments, showing spontaneous generation in sealed containers. Pasteur repeats them, finds contamination. Pouchet argues Pasteur's methods are flawed. The French Academy arranges public challenges. 1864, both men present experiments. Pouchet's fail to control for airborne contamination. Pasteur's controls are airtight. Pouchet loses credibility, withdraws from the debate by 1865. Pasteur wins, not because he's louder, because his experiments can be repeated by anyone and produce the same results. That's the method. Build something so solid your enemies have to accept it or look foolish. If microorganisms cause fermentation, and fermentation is a form of decomposition, do microorganisms also cause disease? This is the jump that terrifies and excites him. The germ theory of disease is not new. Girolamo Fracastoro proposed it in 1546. Marcus von Plinces expanded it in 1762. But these were theories without proof. Pasteur has the proof mechanism: microscopy, controlled experiments, reproducible results. He has the will to push into the most dangerous territory of 19th century science, challenging the medical establishment. Wines turning acidic have a third: specificity again, one microbe, one disease. He tests heating the wine to between 55 and 60 degrees Celsius, hot enough to kill the microbes, cool enough to preserve flavor. It works. The process is patented in 1865, later extended to beer and milk. We call it pasteurization. But here's what Pasteur is really doing. He's establishing a framework. Microorganisms are specific. Diseases are specific. Control the microorganism, control the disease. That framework is germ theory, and he's about to weaponize it. Pasteur knows nothing about silkworms. He goes anyway, because the method works on anything. Observe, hypothesize, test. He moves to the south of France, spends 5 years studying silkworm nurseries. He discovers the worms are infected by 2 separate diseases. One he calls pebrin, caused by a microsporidian parasite creating shiny corpuscles visible under the microscope. The other is flasherie, caused by bacteria in the digestive system. Pebrin is hereditary and contagious. Flasherie is environmental. 2 diseases, different causes, different solutions. His handwriting in the laboratory notebooks becomes shakier, harder to read, but the entries continue. This obsessive commitment comes with a cost. 3 of his 5 children die young. Jean at age 9 from typhoid in 1859, Camille at age 2 from a liver tumor in 1865, Cécile at age 12 from typhoid in 1866. He experiences these losses while solving France's industrial and agricultural crises. The personal tragedy doesn't stop the work. If anything, it intensifies it. Pasteur becomes more driven, more competitive, more willing to sacrifice everything for scientific priority. For Flacherie, he introduces hygiene protocols, clean environments, screened facilities, careful monitoring. The silk industry recovers. Pasteur publishes his findings in Études sur la maladie des vers à soie in 1870. But here's the pattern. He's not just saving silkworms, he's proving the method scales. Fermentation, wine, silkworms, each time the same process. Identify the microorganism, understand its behavior, interrupt its reproduction, solve the problem. The mental process is becoming a system. And here, Pasteur makes the conceptual leap that creates modern immunology. While studying chicken cholera in 1880, his assistant Charles Chamberlain forgets to inject chickens with a fresh bacterial culture before going on vacation. The culture sits on the laboratory bench for weeks. When Chamberlain returns and injects it, the chickens get mildly sick but survive. Pasteur could dismiss this. Dead bacteria. Failed experiment. Try again. Instead, he sees the question nobody else asks. Why didn't they die? He injects the same chickens with fresh, virulent cholera bacteria. They survive again. The weakened bacteria made them immune. Pasteur realizes exposure to weakened microorganisms can train the body to fight the virulent form. This is the birth of attenuation, weakening pathogens to create vaccines. He announces this to the Academy in 1880. But he doesn't just announce, he demonstrates. Koch's methods are more rigorous in some ways. He develops techniques for growing pure bacterial cultures on solid media using agar jelly. He uses dyes to stain bacteria, making them visible under microscopes. He employs the newly invented photography to document his findings. When Koch identifies the bacteria causing tuberculosis in 1882 and cholera in 1883, it's methodological perfection. Pasteur's approach is more empirical, less systematic. The rivalry becomes personal. They meet at the 7th International Medical Congress in 1881. Within months, Koch publishes criticisms of Pasteur's work: impure cultures, methodological errors, unsupported conclusions. Pasteur responds with fury in speeches to the French Academy. Koch fires back, accusing Pasteur of keeping methods secret and jumping to conclusions. This isn't just scientific debate. It's proxy warfare between France and Germany, still bitter from the Franco-Prussian War of 1870 to 1871. Pasteur's son, Jean-Baptiste, fought in that war. The humiliation of French defeat drives Pasteur to beat the Germans in science, since France lost to them in combat. A veterinarian named Hippolyte Rossignol, skeptical of Pasteur's vaccine claims, proposes a public experiment at his farm in Pouilly-le-Fort near Melun. Pasteur accepts on April 28. The terms are brutal: 58 sheep, 2 goats, 10 cattle, half vaccinated, half not, then all injected with virulent anthrax. Results observed publicly. If Pasteur's vaccine fails, his reputation dies. If it works, he becomes immortal. The stakes are national. The Franco-Prussian War ended 10 years ago with France humiliated by Prussia. Pasteur is battling German microbiologist Robert Koch for scientific supremacy. This is science as warfare. The moment. All animals injected with fully virulent anthrax bacillus. June 2nd. Over 200 observers gather: journalists, government officials, veterinarians, farmers, military officers. Pasteur arrives to applause. The results are undeniable. All vaccinated animals alive. All unvaccinated sheep dead or dying. The 4 unvaccinated cows are swollen, feverish, near death. The vaccinated cows are healthy. Pasteur's report to the Academy on June 13, 1881, declares victory. The vaccine works. The public reception is sensational. Pasteur is a hero. His notebooks show he used potassium dichromate, a chemical method developed by his rival Jean-Joseph Henri Toussaint. Pasteur's oxygen method didn't work reliably. Chamberlain, his assistant, secretly prepared the chemical vaccine to ensure success. Pasteur never credited Toussaint, never admitted the switch. Why? Because Toussaint announced his vaccine first in July 1880. Pasteur couldn't accept second place. His notebooks record his private reaction to Toussaint's announcement. This result overturns all the ideas I had. He adopted Toussaint's approach, claimed it as his own, and built his legacy on a lie. This isn't speculation. It's documented in Pasteur's own handwriting, held at the Bibliothèque Nationale, examined by Guizon after decades of family restriction. Willing to bend ethics to win, the vaccine worked, animals were saved, human lives were protected. But the cost was truth. Pasteur built his reputation on meticulous honesty in experiments, then violated that honesty when the stakes were highest. Guizon's book, published in 1995, 100 years after Pasteur's death, reveals this pattern repeats. In his work on optical isomers and tartrates, Pasteur minimized his mentor Auguste Laurent's influence to distance himself from Laurent's political radicalism. In his rabies vaccine, he rushed human trials before adequate safety testing, risking lives to claim priority. It's universally fatal once symptoms appear, over 99% mortality. It affects both animals and humans, so he can test on animals, then transfer to people, and it's terrifying. The disease carries mythological weight. People bitten by rabid animals face certain death after an incubation period of weeks. Pasteur can't isolate the virus. It's too small for 1880s microscopes, won't be seen until 1962 with electron microscopy, but he can work with infected tissue. He takes spinal cord from rabid dogs, inoculates rabbits by drilling into their skulls and injecting cord material under the dura mater, passes the infection from rabbit to rabbit 20 to 25 times. The virus becomes more virulent in rabbits, but paradoxically weaker in dogs. He dries the infected spinal cords in sterile air. The longer they dry, the weaker the virus becomes. Fresh cord, 15 days dried, 14 days dried, 13 days, each progressively more dangerous. He develops a protocol. Start with the weakest dose, 15 days dried. Inject daily with progressively fresher cord. By the end, the animal is exposed to fully virulent virus but survives because the earlier exposures built immunity. Pasteur faces a decision. The vaccine has never been tested on humans. Émile Roux, his chief assistant, refuses to administer it. Too dangerous, too unreliable. But Alfred Vulpian and Jacques-Joseph Grancher, two physicians, argue the boy will die anyway. Pasteur decides. Grancher administers the first injection on the evening of July 6th, using spinal cord dried for 15 days. Since June 21st, over 10 days, 12 more injections. Each one progressively fresher, more virulent. Pasteur watches, waits. Meister survives, never develops rabies. Pasteur presents the case to the Academy on October 26, 1885. The response is explosive. He saved a child from certain death. Patients pour in from around the world, hundreds treated in the first months. Pasteur's fame becomes global. The vaccine used on Meister was not the same protocol tested on dogs. Pasteur modified it in real time. The success rate in dogs was 62%, almost a coin flip. Roux refused because the risk of causing rabies with inadequately dried cord was too high. Pasteur went ahead anyway. Was it courage or recklessness? Wisdom or hubris? We can't know his inner state. We know the outcome. Meister lived. The vaccine worked. But it was Roux's method, drying the spinal cords, not Pasteur's original approach. Roux received no credit until the notebooks were examined a century later. Pasteur took the glory, built the Pasteur Institute on it. The French government funded it in 1888 specifically to produce rabies vaccines. Pasteur directed it until his death on September 28, 1895. If you value documented history and factual analysis like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Now back to the information. Pasteur saw patterns, microorganisms behaving in specific ways. Second, isolation of variables. Swan-neck versus straight-neck flasks, vaccinated versus unvaccinated animals. He stripped away everything except the one thing he wanted to test. Third, reproducibility. He didn't trust single results. He repeated experiments, documented conditions, made sure anyone could replicate them. Fourth, controlled progression. He didn't jump from fermentation to human vaccines. He moved step by step. Fermentation, wine, silkworms, chicken cholera, anthrax, rabies. Each success built credibility for the next. Fifth, public demonstration, Pouilly-Lefort, the rabies vaccine. He didn't just publish in journals. He proved it in front of crowds, made it undeniable. He hid methods when revealing them would cost priority. He minimized rivals' contributions. He rushed human trials when animal data was insufficient. He lied about the anthrax vaccine. Geisson documents this, not to destroy Pasteur, but to show the reality of science. It's done by humans with egos, ambitions, fears. Pasteur wasn't a saint discovering eternal truths. He was a fighter in a brutal competition for funding, recognition, and historical legacy. His genius was real, his dishonesty was real. Both shaped modern medicine. Lister realized compound fractures, bones breaking through skin, became infected because environmental microbes entered the wound. He applied carbolic acid to surgical sites and instruments. Mortality from surgical infection dropped from 45% to 15% within a decade. Public health reforms followed. The British Public Health Act of 1875 mandated clean water and sewage systems because authorities finally accepted that contaminated water spread cholera. John Snow's statistical work linking cholera to the Broad Street pump in 1854 made sense once germ theory explained the mechanism. Vaccines for diphtheria, tetanus, tuberculosis, all built on Pasteur's attenuation method. Paul Ehrlich's development of Salvarsan 606 in 1910, the first synthetic antibiotic, came from understanding that microbes cause disease and chemicals can kill them. Complex interactions between genes, environment, and microbes. Pasteur's framework, one microbe, one disease, one cure, breaks down. Modern medicine is still wrestling with this. Autoimmune diseases, cancer, neurodegeneration. These don't fit the Pasteurian model. The mental process that revolutionized 1880s science becomes a cage in 21st century biology. We keep looking for single causes when the reality is systems, networks, emergent properties. Pasteur's legacy is not just what he discovered, but what his success trained us to expect. Simple answers to complex questions. Geisson argues they reveal something crucial about how science actually works versus how we mythologize it. We tell stories of lone geniuses having breakthroughs through pure reason. The reality is messier. Competition, politics, nationalism, personal ambition. Pasteur wasn't just battling microbes, he was battling Robert Koch for German-French scientific supremacy in the shadow of the Franco-Prussian War. He was battling materialist philosophers for control of the cultural narrative about life's origins. He was battling for funding from a French state desperate to rebuild prestige after military defeat. Science isn't separate from culture, it's embedded in it. Pasteur's methods, both experimental and political, can't be separated. He knew Toussaint's chemical method worked better. He used it at Pouilly-le-Fort and lied about it. He knew the rabies vaccine was untested in humans. He used it anyway. Why? Because waiting meant someone else would do it first. Priority in science isn't just about ego. It determines funding, institutional power, the ability to do more work. Pasteur understood this. He played the game ruthlessly. And because he won, we remember him as a hero. If he'd failed, if Joseph Meister had died of the vaccine, if the anthrax trial had collapsed, we'd remember him as a reckless charlatan. The difference between genius and madness is often just the outcome. Control everything else. Document meticulously. Repeat until the results are undeniable. Then demonstrate publicly so the world has to accept it. This process works. It transformed medicine. It saved millions of lives. Pasteur didn't invent it. Francis Bacon, Galileo, Isaac Newton all used versions of the scientific method, but Pasteur weaponized it for biology. He showed that invisible causes, microorganisms, could be proven to exist through indirect evidence. You can't see bacteria in the air, but you can design an experiment where their presence or absence produces different results. That's the leap. From direct observation to inferred causation through controlled experiment. In 1995, when Geisson's book was published, the scientific community had a crisis. Do we throw out Pasteur? Do we rewrite the textbooks? The answer was complicated. No, we don't discard his work. The experiments were real, the vaccines work, the framework is valid. But yes, we acknowledge the man was flawed, competitive, willing to deceive. We separate the method from the mythology. The method is what matters. The person executing it is always going to be human, which means imperfect, political, sometimes dishonest. The genius of science isn't that it's done by perfect people. It's that the method forces even flawed people to produce verifiable results. Pasteur could lie about how he made the anthrax vaccine, but he couldn't fake the vaccinated sheep surviving at Pouilly-le-Fort. The public demonstration made the result independent of his honesty. That's the mental process that changes how you see reality. Not trusting authority, not believing genius, not assuming purity, but building experiments so airtight that even liars can't manipulate the outcome. Pasteur understood this better than anyone. He knew he was dishonest in some areas. He also knew his experiments were solid. The dishonesty was in the narrative. How he got there, who he credited, which methods he used. The honesty was in the results. 24 sheep vaccinated, all survived. 14 injections in Joseph Meister. He never developed rabies. Those facts stand regardless of Pasteur's character. That's the power and the limitation of the scientific method. It produces truth through process, not through the virtue of the scientist. If he'd been more cautious, more ethical, more willing to share credit, would he have accomplished as much? Maybe, maybe not. Science rewards priority. The first person to publish gets the credit, the funding, the legacy. Pasteur knew this. He sacrificed honesty for speed. We got vaccines faster because of it. Is that a good trade? Geisson doesn't answer that question. He just presents the evidence. Pasteur's notebooks, compared with his public statements, reveal systematic deception. Not about the core results, those were real, but about methods, influences, and risks. The question for us is whether the ends justify the means. Millions of lives saved versus scientific ethics violated. There's no clean answer. Microbes, disease, transmission, prevention, vaccine. Each step connected. He didn't just identify problems, he engineered solutions. And he didn't just discover solutions, he He demonstrated them so compellingly the world had to adopt them. That combination, rigorous experiment plus public spectacle, is what made germ theory dominant. It wasn't enough to be right. He had to make being right undeniable. Pouilly-Lefort did that. 200 witnesses watching vaccinated sheep survive what killed unvaccinated sheep. No theory, no debate, no philosophy. Just stark, visible proof. Pasteur did this across fermentation, spontaneous generation, wine diseases, silkworm infections, chicken cholera, anthrax, and rabies. 7 different fields. Same method, same mental framework. Observe, hypothesize, isolate variables. Test, document, repeat, demonstrate. That framework is his real legacy, not the discoveries themselves. Those would have been made eventually by someone, but the method that made them inevitable. The lies, the suppressed credit, the rushed human trials. Joseph Meister lived, but Pasteur's notebooks show he had no solid basis for confidence the vaccine would work. He gambled with a child's life and won. If he'd lost, we'd condemn him. Because he won, we celebrate him. That's not science. That's luck weaponized by skill. The skill was real. The luck was essential. We remember the skill and forget the luck. That's the mythology Geisson dismantles. Pasteur wasn't a genius who always knew the right answer. He was a brilliant experimenter who made calculated risks and survived enough of them to become a legend. He forced it out through controlled violence against microorganisms, theoretical opponents, and sometimes scientific ethics. He built instruments, swan-neck flasks, attenuation protocols, vaccination schedules that made invisible truths visible. He built coalitions, academy support, government funding, public acclaim that protected him while he worked. And he built myths, the lone genius, the selfless savior, the father of microbiology, that obscured the reality of competition, deception, and risk. You document everything so your victory can be verified. You demonstrate success so overwhelmingly your enemies have to surrender. And if you have to bend the truth about how you achieved it, you do, because priority is everything. That's the mental process, not discovering truth, conquering it. The last entry in Pasteur's laboratory notebooks, written weeks before his death in September 1895, records final measurements on a rabies vaccine batch: temperature, duration, desiccation level. He was 72, half paralyzed from a stroke in 1868. Still documenting, still controlling variables, still trying to perfect the method. The man was dying, but the process lived on. That's the real genius. Not the individual insights. Spontaneous generation is false. Microbes cause disease. Attenuation creates immunity. But the systematic approach that makes insights repeatable, teachable, improvable. Every microbiologist, immunologist, and epidemiologist working today uses some version of Pasteur's mental framework. They might not know his name. They definitely don't know about the lies. But they're thinking his thoughts. Isolate the variable. Control the environment. Document the result. Scale the solution. That's Pasteur's brain running in billions of people. He died in an asylum while women kept dying of puerperal fever from doctor-transmitted infections. Pasteur's work vindicated Semmelweis posthumously, but the resistance wasn't stupidity. It was paradigm defense. People fight viciously to protect their understanding of how the world works, even when the evidence contradicts them. Pasteur won because he didn't just present evidence. He made the evidence so overwhelming, so publicly undeniable, that resistance became impossible. Pasteur put healthy sheep next to dead sheep in front of 200 witnesses. No abstractions, no debates, just life and death. That's how you change reality, not by convincing people with arguments, but by showing them results they can't ignore. The mental process is about designing reality tests that produce clear winners and losers. You create conditions where your hypothesis survives and competing hypotheses die. Then you make sure everyone sees it happen. The evidence of Pasteur's most dramatic experiment is still in the earth, but so is the evidence of his deception. Chemical analysis of the spores shows potassium dichromate markers consistent with Toussaint's method, not oxygen attenuation. The ground doesn't lie, even when Pasteur did. The physical evidence preserves the truth. That's the final irony. The method, careful observation, documentation, physical evidence, eventually exposes the methodology's corruption. The scientific process is self-correcting. It took over a century, but Geisson's work and modern analysis revealed what Pasteur hid. The truth emerged because the method demands it. You can lie about how you got the result, but you can't fake the result itself, and eventually, someone will check your work. That's the mental process Pasteur gave us. Not perfect honesty, not pure reason, but a system that outlives individual deception because it's based on physical reality, not human authority. Germ theory survived Pasteur's lies because microorganisms don't care about human integrity. They behave according to their nature. Observe that behavior carefully enough, control it precisely enough, and you can manipulate reality regardless of your character. That's terrifying and liberating at the same time. Terrifying because it means science can be done by flawed, dishonest people and still produce truth. Liberating because it means truth doesn't depend on the virtue of the scientist. The experiment is more honest than the experimenter. So the mental process that proved germ theory and changed how we see reality is this. Observe obsessively. Notice what others ignore. Ask why things happen the way they do. Design experiments that isolate causes. Control everything you can. Document everything that happens. Repeat until the pattern is undeniable. Then demonstrate it publicly in a way that makes denial impossible. Be willing to fight for priority. Be willing to bend ethics when necessary, but never fake the core result because reality will eventually expose you. That's what Pasteur did. That's what worked. That's what we inherited. Not the myth of the noble scientist discovering truth through pure reason, but the reality of the aggressive experimenter forcing truth out of nature through controlled violence, strategic deception, and public demonstration. And the last word belongs to the experiment itself. Those swan-neck flasks Pasteur designed in 1861. Some are still at the Pasteur Institute in Paris, still sealed. The broth inside still sterile, 164 years later. No spontaneous generation, no contamination. The experiment running continuously for over a century and a half. That's the proof that survives all deception. Not Pasteur's honesty, his experiment's integrity. The method works even when the man doesn't. That's the mental process. That's how you prove germ theory. That's how you change reality, not by being perfect, by designing tests that are